Hey, Algebra 2, this is Chapter 6.6b. We are continuing with function operations. This is composition of functions. Far left, if we have f of x equals 3x minus 2 and g of x equals x squared, we have two functions. We're going to use a function machine and start with an input of 2. Meaning, we're going to take this 2 and we're going to throw it in this machine and see what we get. When you throw it in here, or put it in for the x, we're going to get 3 times 2, which is 6. 6 minus 2, which is 4. Then we drop that 4 down, keeps dropping, drops into the next one, which is x squared. If we square 4, you get 16. Okay? So what did we do? We actually took f of 2 and got 4. Then we took g of 4, or the g function, and got 16. So put them together, g of f of 2 equals 16. So if we try g of f of negative 3, well, where are we going to start? We're going to start inside first. So we're going to start with the f negative 3. We're going to plug that into the function of 3 times negative 3 minus 2 gives us negative 11. Now we're going to take that negative 11 and plug it into the g function. So g of negative 11 equals negative 11 squared. So 121. What we're doing is we're starting with one function and then applying another function afterwards. Okay, so composition of function is when the output of one function becomes the input of a next function. Okay, notation, we're simply doing this. We're saying that f of g, not times, is equal to f of g x, or we can write it f of g of x. So this and this are both the same, or written the same. So number 1, we're going to take g of h of 3, or written g h 3 if you need to. Okay? So we're going to input the 3 into the h function. Okay? So h of 3 equals 5 times 3 minus 2. 15 minus 2 equals 13. Now we're going to take that 13, plug it into the g. So g of 13 equals 4 times 13 squared. So 4 times 169, which equals 676. Okay, 2. Now we're going to do h of f. Okay, which is actually written, because we might be confused, h of f of x. So we're just taking the actual whole function. So take the f function and plug it into h. So h of 2x plus 3 is equal to 5 times 2x plus 3 minus 2. Distribute 10x plus 15 minus 2, 10x plus 13. Okay? And the last one, we want g of f of x, which is g of f of x written. So start with your f function, and we're going to input it into the g function. So take your 2x plus 3, and we're going to put 2x plus 3 in here, and put that into the 4, and then 2x plus 3, and square it. So this becomes 4 times 4x squared plus 12x plus 9. Okay, distribute the 4 through, and you get 16x squared plus 48x plus 36. Putting this all together, application of composite functions. So we have a computer store is offering $40 rebate along with a 20% discount if x is the original price of the item. Okay, what we're trying to do is we're trying to figure out, should we take $40 off first, then apply 20%, or should we apply 20% off first, then take $40 off? So if we start on the far left, if we know dx, well, dx, if we write a function that represents the sale price after the 20%, which means we retain 80%. So if we retain 80% of the price, and the x is the times that original amount. So if we need to find d of r of x, meaning d r x if we need to, we're going to take our d. So d is going to be, the r is going to be the rate off, so we're going to take off the $40 first, By taking the $40 off first, we have 80% of our money. This will be x minus 40. So our answer is 0.8x minus 32. So 80% of our money minus the $32. Now over here on the right, if we switch it and we go $40 after or off of the sales price first, we're going to take x minus the 40. That's going to give us our amount first. So r of d of x, what's going to happen is we're going to take the rate, and then times 80% of the total amount first. So take 20% off first, then apply the $40. Okay, we end up getting 0.8 x minus 40, just so that we know. We're substituting this in for here. Okay, so explain which one. Well, the first one, what we're doing with d of r of x, the customer gets the $40 rebate, then gets 20% off. Okay. With the second one, the customer gets the 20% off, then gets the $40 rebate. Dun dun dun. Which one is better? Hopefully you guessed it. Yes, the RD of X is the better deal. So, taking the 20% off first, then getting the $40 rebate, that is the better deal.
And they stay there.
Congratulations, composition of functions. And again, do your best, forget the rest. Bye. Bye.